Alright, here are the video lesson notes for section 2.1. A lot of this is familiar all the way back to Algebra 1 for the most part. It's just solving quadratic equations by factoring and completing the square. You know the other method is the quadratic formula, and you'll see that in the next section. So just some basic review of factoring here for the first few. In a case like this, we'd be just looking to factor out a common factor of x. Anytime you factor, whether it's with a common factor, a difference of squares, a trinomial, any of those, any time that you factor, the rule is simply, since the whole equation equals 0, I take my factors and set each factor equal to 0 to get my solutions. So in a case like this, if I factor out the x, then x would equal 0, x minus 12 would equal 0, so I get these two solutions here. So almost every case is going to give you two solutions. We'll see one here in a minute where it's not two solutions, but in almost every case you can expect two answers. So here's just another case where I could factor out a common factor of 3x. I would set each factor equal to 0 and get my two solutions of 0 and negative 28. Trinomial factoring, these are the ones where you were looking for two numbers that would multiply to be 36 and would add to be negative 13. So in this case, negative 4 and negative 9 would multiply to be this guy, and they would add to be this guy. So that makes my two factors with negative 4 and negative 9. If I set each one of those equal to 0, then I get my two solutions that you see here. So this would just be another one of the same. This is one you could use for practice. If you want to pause the video, give it a try. Down here, this is just another method of factoring. Because it's a minus, we call it a difference of two perfect squares, because I can take the square root of this guy and the square root of this guy to get my factors. So the first term, if I took the square root of x squared, I got x as my first terms. The square root of this would be my second terms. You make one positive, one negative, and that's it. Factor in those. In a case like this, if you were to factor two numbers that multiply to be 81 that add to be 18, would be positive 9 and positive 9. Because they're both the same, you're only going to get one solution. So this is one of those rare cases where you only get one answer instead of two answers. These guys can just be a little bit tougher for factoring as soon as you throw that number in front. I know there's multiple ways of factoring. A lot of times people have sort of a guess and check method. There are other methods, so if you're not a fan of the guess and check method, if you ever want to see some other methods that I think are easier, ways of factoring trinomials that have a value in front other than 1, come on in sometime and ask me, and I'd be happy to go through one or two methods that I think you might find are a little easier than just a guess and check method of solving for these. Here's a case where if I recognize that 2 can be divided into every term, I can just divide the entire thing by 2 and get rid of it, and that's going to give you something that's easier to factor. So you wouldn't have to do that. You would still get the same solutions if you factored from here. It's just easier to factor if you get rid of the 2, and it's easier to work with from there. Moving down, if you get a case like this where you know it's a quadratic, because if I multiply these together, or FOIL as most of you know it, I do get the quadratic setup that you see here. Any quadratic, when you're going to solve it, we always like it to start by equaling 0. So if we just subtract the 3 over and add 2x over, make the whole thing equal 0, and then you're right back up to solving by factoring the way we just did it up above. You get a couple questions like this that are going to make you think outside the box just a little bit. So we're going to make use of just some given information here to set up our own quadratic to solve. In this case, we know we have a perimeter of 40 and the hypotenuse of 17. So, and that's all that we're given. So if I got to find the lengths of the other sides, I'm already thinking Pythagorean theorem because it's a right triangle. So a little a squared plus b squared equals c squared. But in order to set that up, I need some value to represent each side length. We know the hypotenuse was 17, that was given. I'm going to call one leg x just to identify it as something. Since the entire perimeter was 40, Well, that means if all three sides add up to 40, I can subtract x and 17 from 40 to get an expression for my third side. And if I clean that up a little bit, it's just going to be 23 minus x. But by doing that, I now have some expression to represent all three sides, so now I can plug it into Pythagorean theorem and get something that's solvable from there. For the second part, I'm going to stray a little bit from the notes that you see here. This was done in a little bit of a different manner than what you probably learned it, so I'm going to address this idea, but I'm going to show you the method that you probably would have learned it in the past, as well as the way our book teaches it. So I'm going to stray from here in just a minute, but the idea is we're using a completing the square method of solving. Typically, completing the square works when something is not factorable. In a case like this right here, if I wanted to solve this by factoring, well, there are no two numbers that would multiply to be 13 and would add to be 8. So if it's not factorable, I need some other method for solving, and that's where completing the square comes in. So let me go to sort of the method that I would do on this. This would be the method or the way that you would have learned it in the past. The idea is we're going to create a perfect square trinomial, and a perfect square is just simply a trinomial where both factors are the same factor. So we have our ax squared plus bx. To get the c value, we have a little formula that you've seen in the past, b over 2 squared. This is going to create the c value, which causes a perfect square for us. Just a reminder that anytime you have a number other than 1 in front of x squared, you have to factor out this value before completing the square. And you'll see a couple examples of that here in just a minute. I'm going to show you one idea on this first example. I'm not going to do this on every one. I just wanted to show you where this is headed and give you an idea of something that will help you with some upcoming sections. If I go through the normal completing the square process on this, we would always start by taking our c value that's currently there and moving it over to the other side. So I'm going to take that 7, bring it over here, which would then be negative 7. I then need to complete the square by using this formula. So if I take my b value, which is negative 10, if I divide that by 2, I get negative 5, and square it, I get 25. So I'm going to add 25 as my c value to create a perfect square, and whatever you do to the left side, you got to do to the right side. So I added 25 to both sides. A little cleanup here on the right side, but the left side you can see, because my factors are the same, if I were to factor this, my factors would be x minus 5, x minus 5. Because they are the same, I can write it as x minus 5 squared. And that's the key to completing the square. That's why we create the perfect square, is because now I can solve this algebraically from here. So at this stage, from this line right here, I can now square root both sides to get this look. Don't forget to throw in the plus or minus anytime you square root both sides of an equation. Add the 5 over, and we get this answer here. Let me just remind you of this concept right here. You're going to use it in some upcoming sections. At this stage, if I would have subtracted the 18 over to here, we get a format for this quadratic that's called vertex form. At least most books call it vertex form. But vertex form is going to be nice for some future use with graphing and things like that. With this format, you can look at the numbers and just see the vertex of this parabola. So it would be positive 5 and negative 18. So that goes back to this setup that you see right here. P and Q represent the vertex of this parabola. So this is an idea that if you just wanted you to see it, because it might be helpful for some upcoming sections where you're asked to maybe identify a vertex or to graph or something like that. So I just wanted to remind you of what that looks like. But moving forward, again, on any of these, feel free to just pause the video and try one on your own before hearing my explanation. These are all somewhat similar, so at any point I would encourage you to stop and give one a try and then watch the explanation and make sure that you're doing it correctly. But I'm just following the same steps. I'm going to take my c value that's currently here and move it over to the other side, so it's going to become positive 4 on the right side. And I then need to complete the square by doing my b value divided by 2 squared. If I do that, I get 49 over 4. So that's what's being added to both sides of the equation. Don't forget to do it to both sides. It's a really common mistake to forget the right side. Little cleanup on the right side, if I create common denominators and add those together, I get this. On the left side, my factors in factored form would look like this. With fractions, it can be hard to figure out what your two factors are. I think the little shortcut, the easiest way to see this, is whatever you have right here in parentheses, b over 2, is what's going to be right here in parentheses. So in this case, 7 over 2 is my b over 2 value. So that's just one way of figuring out what this number needs to be. In some of the cases, it might be a little tougher like this one. But anyway, once you get to this stage, I can now square root both sides. So here's the next line that you would see. Don't forget your plus or minus. And then we're going to subtract the 7 over 2 over to this side and end up with this look here. Do simplify if possible. So instead of having the square root of 4 on bottom, we know the square root of 4 is 2. So this would be the more appropriate look for that one. So for C and D, for the last two, these are cases where your A value is not 1. And so we're going to need at some point to factor that number out in order to complete the square. Start the same way, add your 9 over to the other side. But before I complete the square, I'm going to factor out a 2 from these terms. So that's going to give me this look here. I then complete the square. The key on this one, though, is recognizing that I did not just add 9 to the left side. I added 2 times 9 to the left side, which is really 18. So I need to add 18 to the other side to keep my equation balanced. But the rest of this would play out the same as the ones before it. So clean up on the right side, divide both sides by 2, square root both sides, and then add the 3 over. In this case, if you simplify the radical on top, you're going to get this look here. With IB, you can leave a radical on bottom unless the directions say otherwise. So this would be an accepted answer. If you don't want to leave the radical on bottom, you can multiply by rad 2 over rad 2 and get this look here. So either answer would be accepted, but you would just need to check the directions to see if they specifically ask you for some form, and that's always important. On the last one here, if you just rearrange it properly in the proper order, similar to the order that you see right here in part C, you're going to get this look to start things out. And again, if you want to pause it at this point and give this one a try, that'd be a good thing to do. But otherwise, I'm going to factor out my 3. I'm going to complete the square by adding 4. Remember that I didn't just add 4, I added 4 times 3 to the left side of the equation, which means I also need to add 4 times 3 to the right side. But after you go through a little cleanup on this, plays out the same as the other ones. And then again, you got the two options for how you could write your answer. This would be accepted unless the directions say otherwise. This would be another way to do it if I didn't want to have a radical on bottom.